differentiating and integrating power series. Examples, consider the geometric series f of x equals 1 over 1 minus x as a summation of x to the power k from 0 to infinity, or as the expanded form 1 plus x squared, and so forth, for the absolute value of the x less than 1. Part A, we are going to differentiate the series term by term to find the power series for the f prime and identify the function it represents. As f of x, which is 1 over 1 minus x in the expanded form, as the summation of the x to the power k, 1 plus x squared plus x to the third plus x to the fourth, and so forth, and k from 0 to infinity. We find the derivative of the summation for k from 0 to infinity. That means we find the derivative of 1 plus x squared plus x to the third plus x to the fourth, and so forth. And we derive 0 plus 1 plus 2 times x plus 3 times x to the second plus 4 times x to the third. If we keep going, we would get 5 times x to the fourth. And then we can rewrite this as a power series in the form of the summation k multiplied by x to the power k minus 1 for k starting from 1 to infinity. If you starting at 1, k equals 1, 1 times x to the power 0, which is the first term here, and then for k equals 2, we have 2 multiplied by x to the 2 minus 1, which is the second term, and so forth. So we derive the series form of the derivative. How about the exact function form? For f of x equals 1 over 1 minus x, the derivative of the function, if we do it directly, or find the f prime, or the derivative of 1 minus 1 divided by 1 minus x, and this is the same as 1 minus x to the power negative first, the derivative becomes negative 1 multiplied by 1 minus x to the power negative second multiplied by negative 1, or simplified to be 1 over the quantity 1 minus x squared. That gives us the function 1 over 1 minus x to the power second is of the power series forms the summation of the k times x to the power k minus 1 for k starting from 1 to infinity. The next part, we are going to integrate the same series term by term and identify the function it represents. For 1 over 1 minus x as a function, in the expanded form, or in the summation of x to the power k from 0 to infinity as 1 plus x squared plus x to the third plus x to the fourth, and so forth. Find the antiderivative of the summation for k from 0 to infinity of x to the power k with respect to x, or the antiderivative of 1 plus x squared plus x to the third plus x to the fourth, and so forth with respect to x. After integrating term by term, the first term we get x, next we get x squared over 2, x to the third over 3, x to the fourth over 4, x to the fifth over 5, plus, and so forth. And write this as a summation, or the series form as the summation of x to the power k plus 1 divided by k plus 1, k starting from 0 to infinity, and then added by the constant c. We obtain the series form. And next, we're gonna work on the function notation itself. The antiderivative of the function f of x with respect to x, or the antiderivative of 1 over 1 minus x with respect to x. This is the antiderivative of negative natural log absolute value of 1 minus x plus c as we use the u-sub technique for u equals 1 minus x and the differential u is negative differential x. Therefore, this summation is the same as negative natural log absolute value of 1 minus x plus c. C and C can be reduced, so then we can represent the natural log absolute value of 1 minus x as negative summation x to the power k plus 1 over k plus 1, k starting from 0 to infinity.